Okay, this is 7.1. This is number 1. And we have the velocity function. V of t equals 5 cosine of t. And first of all, we want to find out with this velocity function on this interval 0 to 2 pi. Okay, when is it moving to the right? When is the object moving to the left? And when is it standing still? So I drew a quick sketch here. So this is a sketch of the cosine. And you know the cosine starts at 1. In this case, we've got an amplitude of 5, so it starts at 5. And then this is pi over here. And that's pi over 2 and 3 pi over 2, so you can see how it's moving. So when it's above the graph, it's positive. That means it's going to the right. When it's below the graph, it's negative, and then positive. So it's pretty easy to figure out. So the A part of this problem, moving right, okay, on the interval from 0 to pi over 2. And it's that's closed, so 0 to pi over 2. Okay, and that's going to be moving also this interval from 3 pi over 2 to 2 pi. And that's still moving at the end of the interval, so you can put that open. So that's when it's moving to the right. When we're above the line, or in the positive area, it's moving left. And we're moving left on this interval whenever it's negative, and that's going to be from pi over 2 to 3 pi over 2. That's when it's moving left. And then stopped whenever the velocity is 0, and that's going to be here at pi over 2 and 3 pi over 2, so we can say it would be stopped at t equals pi over 2 and 3 pi over 2. That's when the cosine is 0. That's not too bad. Okay, and then the next thing, letter B, we want to find the particle's displacement for the given time interval. And then if s of 0 is 3, where's its final position? So it's the B part, so we know that V of t is our 5 cosine of t. And then what we can do is we know that V of t equals ds dt. So that also equals 5 cosine of t. And then I can separate my variables, so I could have that ds equals 5 cosine of t, and then I can integrate both sides. Move that up a little bit. And then we're going to get s, and this would actually be the integral from 0 to 2 pi. And this is going to give me my displacement. So this would actually be my displacement from 0 to 2 pi. And we can call that delta s. So the change in s, or the displacement. And that's going to be, and then I can pull this 5 out, so that's going to be 5 times the integral from 0 to 2 pi. Oh, I forgot my dt, pardon me. Should have moved the t over there, dt over there, pardon me, and then I should have dt over here. I forgot my integral there, or my differential. Okay, so again, move that over there, and then integrate that, so that would be 5 cosine t dt, and this is all set up. And the antiderivative of the cosine is the sine, so that's just going to end up being 5 times the sine of t from 0 to 2 pi. Okay. And if we evaluate that, that's just going to be equal to, if I evaluate this is going to be 5 times. And the sine of 2 pi, remember this is f of b minus f of a. We evaluate this using the fundamental theorem of calculus. So this is going to be sine of 2 pi, but what's the sine of 2 pi? 0 minus the sine of 0, which is 0, so that's just going to be 0. So the displacement equals 0. So if a little bit here. Okay, so if S of 0 equals 3, then my displacement plus my initial position is the final position, which is 3. So that's the final position. Okay. So that was letter B. And then letter C, what we want to do is we want to find the total distance traveled by the particle. So the total distance traveled. This would be 1c. The total distance traveled. The total distance traveled, now that's just going to be, we talked about this before, it's going to be the integral from 0 to 2 pi of the absolute value of 5 cosine t dt. Now remember, and I'll just kind of, do this once so we know, but remember the absolute value of x, okay, that's defined as x if x is greater than or equal to 0, and negative x if x is less than 0. 0 is kind of in between there, so we can use it either place. We could put that equal there or there. But remember, if x is negative, then we take its negative. All right, it's negative x if x is less than 0. So we have to go back and remember our graph. Now remember, this wasn't always positive, so we got to break it up into 3 integrals. And the first one, let's see here, this is going to equal the integral from 0 to pi over 2 of 5 cosine t dt. And remember from our first part of the problem, I can bring this back up here, this was where it was positive, so I'll just integrate this as is. But in this interval, it's negative. So that's like the absolute value of x is negative, less than 0, so I have to take its negative. So I have to negate my integral here. That's going to be negative the integral from pi over 2 to 3 pi over 2 of 5 cosine t dt, and then finally plus the last part, because that again is where it gets to be positive again, so I don't have to negate it here. So plus the integral from 3 pi over 2 to 2 pi of 5 cosine t dt. And remember, the antiderivative of the cosine is just a sine. We've got a constant there. So we're just going to be evaluating this. So this would be 5 sine of t evaluated from 0 to pi over 2, then minus 5 sine of t evaluated from pi over 2 to 3 pi over 2, and then plus 5 sine of t, and that's going to be from 3 pi over 2 to 2 pi. There's your f of b minus f of a. F of b minus f of a, f of b minus f of a. We've got a constant in front. We can factor out the constant if we want, if it makes it a little bit easier for you. I'll just leave it in front for now. So this first part, what's the sine of pi over 2? So that's going to be 1. So it's 5 times 1 minus sine of 0, 0, 5 times 0 minus, and that's going to be 5 times, and what's the sine of 3 pi over 2? Well, that's negative 1 minus 5 times, and the sine of pi over 2 is 1. And then plus this last one, and that's going to be 5 times, and what's the sine of 2 pi? That's going to be 0 minus 5 times, and what's the sine of 3 pi over 2? That's going to be negative 1. Okay, and then this is just going to be 5. And then what's this going to be in here? Well, we have 5. So we have negative 5, and negative 5 is negative 10, times a negative is a positive 10. And then we have 5, and a negative 5 times a negative 5 is a positive 5, so 5 plus 5. Oh, I'm sorry, 5 times 0 is 0. And then negative times a negative is positive, so I got 5 here. So if I add those all up, I get 20. So hopefully that makes sense. And we'll get the next one on in just a moment.